Hey guys, it's Access Denied with episode 14 of developing a YGO sim. So the latest thing that I spent this weekend doing is working on the AI system called Snarky Child. This AI system is slightly different than the others in a number of ways. It originated when I had asked 10K on DevPro if he could gut certain parts of the current DevBot system called WinBot to expose a Lua system. He felt it was better for programmers to write the AI in C#. It's been about 2 years now since that thing has gotten updated decks, and it's not very great. On the other hand, the Percy AI has continued to evolve. So I would like to take us down an evolutionary path similar to that. What we know about the Percy AI is rather limited to just the open source aspects of it and not the actual shell bindings. So I've been spending time working on that. I took the source code that I had been working with for the browser mode, and since it was mostly completed, I started building a shell out of that. So we've gone full circle here. With the AI from last year this time, going down to the browser, getting improvements, now it's coming back up to the AI level with massive improvements, and those improvements are very likely to go back down to the browser eventually, so it's a nice circle. So let's get started with the AI called Snarky Child that is currently on Salvation. I'm just going to go over these really quickly, so you guys can come and look at these files in depth if you want. But basically, it sets up a connection directly to the server in a way that is very similar to a normal user. So once it's connected to that socket, that messaging system, if it gets an event and that event is targeted at it, it will start WinBot. And it's able to start WinBot with a number of parameters, and we're able to get the deck off of it if it's given. So much like Dawn's system, we're able to allow you to pick your deck, and you guys can see that in the interface. But basically all it does is just start WinBot. So the new AI system is really just going to call some Node.js scripting. So I can still take the data for what deck you want to play, but at the same time I can have you send the deck to the server and then have the deck routed into the AI. So you'll be able to duel for whatever deck that you want. Next up, we have the shell system. If you're testing this is the script that you're going to want to run. It takes the room pass as arguments. It starts out by going over into the client system and pulling out all of the decks. You'll see where that's used later. So this is the frame maker function. This is basically a memory buffer. Data comes into it. If it's a message, it sends it out and then takes into the next piece. If it doesn't equal up to a message, it keeps taking information until it has at least one message to send out. And it can hold multiple messages, and it'll send those down through a number of functions that result in piping, which send those individual commands into process task, which sends it over to receive socket, and receive socket is defined in another file. So this is the transformer. During the 2 months that were shut down, I was mostly working on this file. Now, just looking at the top, there's a couple of support functions here, but it starts right about around here. And that should tell you we're starting off on line 200. That's really bad. So those commands come in here. They start out as packets, Actually, no. To fidget. No, keep going. Where's the fucking start point? Okay, almost line 300. The packet's coming through here, and it cases over those packets to figure out what the messages are on those, and then it just pulls data off of them. Just pulls off pieces of data. So like, if it's a new turn message, then tell me who the player is. If you're refreshing a deck, and tell me which player's deck needs to be refreshed. If you're negating a chain, tell me which chain is being negated. If you're asking for more targeting information, tell me about that. And tell me what card you're going to use. If you're paying life points, tell me which player and how much life points they're going to pay. All this does is create data objects and sends them over into the next processing point. That's all this file does. It is all that it does. It doesn't actually do any serious lifting. It doesn't change any state or anything like that, but it requires quite a bit of processing. And this has taken me as long as Salvation has been open to write, and it reflects almost a one-for-one piece of information that is in YGO Pro itself. It's about line for line and cost of rewriting it into JavaScript. Now, after it sends that message, it sends it over to this processor. Now, what this processor does is it's attached to the stream of data that's coming through, and when it receives those messages, it triggers an event. And now we've moved over into that event way of looking like this. When I have a message that says something, I need to do what's here. So, for example, when I have a message saying that I've joined the game, I need to update my data state based on this. I need to do these actions because I got this specific message. And this file has every single message and the actions that need to be taken on each message. So that's pretty easy to understand. It's like it's saying that I won. I need to notify the user that they won. The game started. I need to do everything that I need to do for the game started. It's asking me if I should go first or if I'm picking rock, paper, or scissors. Now, in order to reply to the server, it requires that we go back and reconvert it back into the way that we're receiving messages. And that was actually fairly simple. Starting off, but it could get more complicated in the future. I have the pattern laid out here, and all this does is some buffer building, and it returns those buffers and you can send them back. Toward the bottom there are some helper functions, which are pre-made buffers, which are useful. So now we can talk with the server and we can mostly understand it. But we need to remember what it's telling us. So in order for that to happen, we have this state system. So this is what I spent most of the weekend working on. This state system works by taking the video that you guys saw of cards moving around on the field, those functions, and I rewrote them into pure JavaScript, and I have a representation of those HTML elements. It's just a row of, what's the word here, adjacent DOM elements, and that's reconstructed here as an array of card elements or card objects. Those objects can have quite a bit of data attached to them, but we're just starting off with every single one of them looking like this. So when we get a start command, we just take a blank card and put it on the field for every card that it tells us to create. So that can be approximately up to 60 per deck. It's about 180 cards I'm expecting. It's not really a lot of information to work with. And then I have ways of manipulating those. So there's a number of filter functions. So this allows me to filter on data as I used to with jQuery, which has been very convenient. It takes a little getting used to, and I've had to write a couple of predefined query functions for it. But it's been pretty okay to debug things just in case a query doesn't go through properly and it fails out. I've written the state to file whenever possible. So that's something that you can look at and see how it's being moved around in memory. It's pretty awesome. This is actually the cleanest piece of code related to the AI system. But even then, it does have a weakness, which I'm still trying to figure out, which is the move function. It has issues with XYZ summoning. It can't quite figure out exactly how to understand the overlay units. So I'm still working on that. Last up, we have the Snarky Child AI system, loading that into memory. I ended up working on something, working with something called Lua VM.js. This actually turned out pretty well. It creates a perfectly clean Lua state, but it's attached to an expectation of a browser. And that's gone pretty well, with the exception of a couple of things. The require Lua doesn't work exactly like I was expecting, so I have to physically load and execute every single file. So it manually does all the requires, which is what these two functions are here. Well, 3, and then I've started doing some testing, and eventually I'm just going to be able to call a function inside of it, and it'll work like without any issues. The thing is that it requires quite a few helper functions of sorts. Not going to let me go to it. Okay. So if you look at Snarky's scripts here, he outlines a tutorial here. These functions would start with the AI. I have to create those in JavaScript, and that's going to be the problem. Right now, I can't quite figure out how these things are passing in text quite right. It's behaving very oddly. I don't quite like it. I'm trying not to change any actual information, but I have to write each one of these single functions, and it's going to be quite tedious. After that, I can then go back to the processor.js, and on these commands, these events, just call these, which will be pretty easy, really simple. This might be troublesome. I have to look into it some more. But from there, I've made quite a bit of progress. I mean, like, it's been a year. I guess you guys really deserve to update. So that's been all for me. This has been access denied, connection terminated.